at all. Just doing the ship. We started 1 hour early because we also have digital forensics webinar right after this, and I want to get in time. Don't worry, every material about this is going to be documented, and it will be in styles of presentations, so he doesn't really miss anything by not attending. This one is just okay. So in this case, we're gonna use text editor in order to analyze a file. For the demonstration purposes, I'm going to be using some random file from the internet. So let's find a file. Let's say not OP autocomplete, but what can I exactly analyze or showcase to you guys? So let's say just an auto here. So let's just say an auto, OP autocomplete. These files is what we're going to be analyzing. So first of all, we're going to learn how to detect this application on the system, or how exactly how it has been executed and all that stuff. Okay. So we have OP.exe. Let's assume that the malware or the cheat that the people have used has been renamed to temp drive dot let's say dot actually without an extension. Okay, so without an extension. Just before you go, yes. In 1 hour. Exactly 1 hour. Yeah, and that one is gonna be okay, yeah. That's good. Yeah, so to people who are see you, yeah. So in this case, what do we have here? So let's imagine that we have this executable file which has been modified or renamed. Let's say that it was moved to temp directory. Let's say it was moved to this, not here, actually, what is over my view. Let's say Chrome URL fetcher. So we paste this here, then we also name these some random characters, okay? It's just random characters. And let's say that this is also for the properties, and it is also read-only, and it is hidden, okay? So okay, now the file is gone, the file has been modified, and there is a bypass that people can use. So let's say that now we execute this file. So we go to the temp directory. So let me see the ID of this URL fetcher. Then we go to cd. Oh, oops. Wow. Okay. Not that. We're looking for this. Go to here. Then we go to this directory. So we start this file. Now this file is going to be an autocompleter, although this time you're not used to wmi RSS call create. I forgot what the command is. I'll probably have to use the WMI. Yeah. It is whatever. So now the file has been accessed actually. Now all we have to do now is for the file system or file analysis So the autopsy of a file means that we have to find this file, although it is not an executable. It's also not. It also has no extension, and it also has no. It is also hidden, and it also has read-only attributes, which means that you can't really modify the file. The first thing that we do in those cases is that we go to search everything, and we use the following strings. So first of all, we have to filter out. So if you are looking for extensionless files, so it's the extensionless malware, you go to search everything, you go to search, you go to advanced search, and then you go to, let's say, none of these words, okay, go to .exe. So when you hover over this, it's going to tell you what to do. So you use spaces to separate the words. You don't need .exe files. You also don't need .dll files, because those two are easily different files, right? So those are executable files that have a signature, and it is possible to signature or validify those files with a signature. And then we have the following details. So it is a file size, which we can also modify. Let's say that we want at least 200 kilobytes and at least 30 megabytes. Then you go to the filters. So you go to everything. Yes. We're looking for a bypass. So we're looking for an extensionless file that has been executed. I'm going to tell you, you're going to see what exactly I mean. So just follow for me in this case. So then you have the type of the file. In this case, you only want. You can also select files with no extension, or you can also select files, all file types. In this case, we just do all files and folders. Then you go down, and then you have other different options to choose from. Then you go to OK. This is going to sort all of the files that are on the device with the 9,000 objects. Then what you do next is that you go to File, go to Export, so you're saving the results, and you go to the downloads or wherever you want. Save this as paths.txt, okay, paths. Now you have all the files on the device that are not executable files, that are not DLL files, that are at least 200 kilobytes long and 30 megabytes in size. Minimum 200, maximum 30. You can also modify this and do option 35. That's going to extend the search. Another thing that you can do, export things, is do extension and do space. These would only list extension-less files, so those that don't have an extension, like these ones. This list will also export this as well. So go to File, not like this, go to File, Export, and just do extension-less, okay, .text, okay, very good. Then you go to CMT. Now what you have to have in this case is path parser, paths parser, .exe. This is a tool that Spock has made. It's very useful. So we can move this to the same directory as, the paths folder that we have. And in this case, you go to the same directory as this executable. Go to that, go cd, and do it like this. Then you go to path parser. So if you execute this file, so of course I don't have this runtime. Okay. Oh, wait. Right. So what exactly do I do? So let's just install this for distribution because we're gonna need this eventually. Reinitialize, install this, and yeah, we wait for this a little. Installation successful. Okay, I don't have this either. Okay, wait. So why do I download this? Let's try 64. Okay, I hope this is gonna work this time. Okay, yeah. So then what you do is that you want to scan them for his Yara rules, which he has added. So you just do yes. So why? You can also add your own Yara rules, which we're going to touch later in a different webinar. But this is also possible. But in this case, we don't have our own Yara rules. We also don't look for replacements, and we also don't want to scan for DLL files only. Now, what this does is that it's going to scan all of the files that were found in the paths.txt file, and it is now scanning for signatures. What happens here is that I'm just going to scan for all of the files that have been identified. So this is going to take some time, but it's all going to be worth it in the end. Which means that in this case, there is not much left. So I'm going to show you exactly what to do after this. We're also going to need Timeline Explorer. Do I have this? Yeah, I do. Okay. So after all that, this is going to give you some results. So you have to wait for this completely, because it's going to take some time. Yes, it is also analyzing 9,000 files, so 9,000 files does take a long time. After that, so let's wait for this, I guess. That should be really neat, to be honest. Okay, well, after everything is done, or if you have exported less files, yeah, okay, good. You can copy all of this. You can copy all of this, right click, it's going to copy all of that. Then you can save the results into a different text file. So, for example, results. Another thing you could do is that you just save the file from CMD itself, but you can paste those here. And now you're looking for files that have not been signed. So, like, let's say, not signed. Let's just do this here. Not signed. This is going to find all the files that are not signed on the device. Which means that you are most likely to come across files that are cheats or malware in this case. So let's see if we have waited enough for this to detect rename extensions. No, it doesn't. Okay. This one doesn't detect the rename extensions, but another thing that you can do in these two cases is that you can just go to here and go to here. You know the path parser once again. Of course, rename this extensionless files. Now that you have exported the extensionless files, you go to paths.txt. So you run this, but before running this actually, run this into results 1, 2, 3 text, so that it is gonna save all of the results. No. Yeah, no, this is gonna take some time, because it is, as you see, it's exporting the results right now, thus far. When you refresh this, it's going to take some time. When you cancel this, the results have been saved, so they are still saving, right? Okay, except for this time, this doesn't really show file names. Right, okay. Yeah, that doesn't really show your file names. Okay, wait. So, you have the path parser, you have the paths. The next thing you do here is this, okay? You can also just run this file if you really want to, but the issue here is that it won't really help you scan all of the files on the device, and it's also going to shut down the moment you finalize it. So you just do yes, no, in our case. And we have to wait for this, so that this actually analyzes all of the extensionless files that are located in the paths text. folder, well, this text file. But this thing takes some time. What you're looking for here, exactly, is that, okay, so let's say that it's finished here. What you're looking for here is the file header. So the file is not executable. That's what the MC stands for. It's not an executable file. You know that because we're scanning extensionless files, but you're looking for red highlights, which are sometimes going to show that the file. So you should always pause every time you see red here. Always pause. Use that. Okay, so we saw red. So click on this and scroll up. For example, this one says that there is a volume that has been deleted from the device. Then what you have to do is that you have to just observe this behavior. It is scanning all of those files for extensionless, all of those extensionless files for signatures. So we don't really have any luck right now because this is also analyzing 9,000 files, which means that it's going to take some time. But let's say that it is at least 100 files. Okay. Now what we check here is that is the file signed or is the file not signed? So is it unsigned? We found no detections here. Okay. There's nothing that has been detected or there's nothing that can be accessed here. Now the issue with that is that if you go here in the timeline explorer, you go to files that are extensionless, so plus space, and then you go to date modified, you're gonna see a lot of information of files. And as a matter of fact, there is still a file over here, which is called, and so this one. So this one is still a file, and this is not a legitimate file. So what this has showed us is that even though we exported those paths, we don't really have this file. We don't really have this file analyzed, or we missed the file, which is a high likelihood. Which has a high likelihood of us missing the file. So what do we really exactly do in order to analyze all of those files with this path parser? So there are two methods that we can utilize. First of all, when you go to path parser, right? You go to paths parser, and you execute this. What you have to do is, alright, you go to yes, you go to no. What you have to do is that you should always look for the red highlights over here, but this is going so fast, it is nearly impossible for you to actually detect something, right? So there are detections, like for example, there's a red one over here too. So these ones are over here, those are red, that means that those folders or files are deleted. I recommend that, so this one scans 70,000 files. So I recommend that you pause at least every 10 seconds to analyze this. There are better methods, there are better scanners out there, but for example, just pause here. So you have to analyze the red highlight, which could have been of the flag, which is not the flag. So every 5 to 10 seconds you have to pause. Okay, I would recommend every 5 seconds. So 1, 2, 3, 4, 5. So everything has been analyzed. And you'll notice how this tool did not really catch what we were looking for. The reason to that is that this didn't really scan for file signatures. That means that you are looking for a signature checker, right? So you have to Control F, you paste this, you go find this. This didn't even scan this file because of two restrictions. First of all, it is in temporary files, and second of all, it is hidden. So I don't think that this tool actually scans or analyzes hidden files. So what will we do in this case? We have two options. We can go to the free guide that I've made, which is over here. Right, so you go to here. And you ask it to give you a signature checker. of the script. So you go to home, you go to red lotus, and you go to ask this. This, by the way, this also translates in your language. So if you speak Portuguese, for example, this is gonna give you an answer in Portuguese. So this analysis, yeah. So this analysis is going to help you detect renamed extensions as well as unsigned files. So, for example, not signed. We don't really see this here because, well, this is a terminal, and yeah, this didn't really catch anything at all. So you can go here and you can just go and ask this guy, give me the signature checker script, which is gonna find all of those, which is gonna read all of those guides that I've made. Well, I made those, so I just added them here, and it's gonna give you this. So the little signature checker, which you can also use instead of right. So as you can see, instead of the other one, you can use this. This is going to take some time because it's also analyzing 70,000 files, which is a very slow method. And another issue here is that so you have this, okay? So this is how everything is formatted. You will never be able to find almost anything in this thing. So what do we do next? So this is what we do next. Go to the home, go to the documentation, so the digital forensics, and you ask this to give you a Yara sample rule. Here's what we're gonna do. So we're gonna take this file that we have such a hard time detecting, right? So this file is a very hard thing to detect with those scanners alone, okay? With those it's not really that hard of a file to detect. So what we're gonna do now, I'm gonna teach you, is how to create a Yara rule that matches, that is very simple to use. How do I know? That's the point. We're gonna create a universal detection, which means that the file doesn't have to be this one. But it will detect every that I need to look for that. Oh, this is something you should do at the start. This is something you should do at the start, to be honest with you. Because, yeah. So, the first thing you do is go to the Yara sample, Yara rules sample. And this gives you an example of, for example, of the rules. Okay, like this one, for example, all of those are samples. And then you have that link to their rules. Okay, so this one. So you can take any of those. So let's take this rule. And I'm going to explain to you how this really works. Okay. So you can create a text file if you want to. You can also create another type of document, but this time you're going to do extensionless, and then just do YAR, right? Because this is a YARA rule, and this is the extension for YARA detections. Open this as Notepad and paste this rule here. And then we have all of those rules. Those are strings that we have. We need at least two of them, okay? Or at least three of them. We have the rule name. The rule name is, in this case, extensionless. Okay, extensionless. With the strings. First is executable files, which is gonna be this program cannot be run in DOS mode. This is gonna find all the executable files that have been renamed. The second one is going to be the elevation of the file. So in general, what you need is that you have to go all the way down to find the execution policy of this of those files. For example, execution policy. Oh, let me just do search all. Let me just do strings. So let's say the administrator, because this one doesn't run as administrator. So you're gonna have to find the run as. It's not this. Wait. So how about equals and these? So yeah, I'm still looking for. Yeah, I think it's this one. Yeah, it's this. So we have to find how exactly the file is being executed. So in this case, we have UI access, and we also have the level as invoker, which means that, so this level, right? So this is something of the file. Okay, wait, let me respond to this guy, and I'm gonna explain everything to you. But by the way, are you recording this or not? Yes. Okay, that's good. Mm, okay. So let me see. The lesson over here. So if you have sharing the screen, right? Okay. So we have the level. So execution level. This is what you're looking for in all of the files. There are several types of execution levels. You're looking for anything that is run as administrator or as invoker. So you can add both of those rules here. As administrator, whoops, level as administrator is administrator. Actually, you only need the as admin as it is. Okay. Sometimes you also add ASCII so that it only looks for ASCII values of them. So then you can do as invoker. Okay. You have the condition. Okay. So this is an example, a standard example of all of those. And what you do now is that. Okay. So what you do now, this is very important. Okay. So you have the content of the file. What you do now is that now that you also have the YARA rule, you can execute things one more time. Okay. You can not this. You can open CMD one more time. So pay attention to this one because it's going to be very useful for you. By the way, also if you record this, I think it's better if you also send me the recording because there are beginners who might want to learn this, or you can keep it for yourself. It's both. No, you can keep it for yourself. To be honest, it's just, or you can also like not record because I'm gonna be making PowerPoint on this. Up to you, but I'm showcasing all of those to you specifically. So if you have any questions, okay, very good. Okay, very good. If you have any questions, make sure to ask me. Don't hesitate to ask me. So then we have the path parser. Okay, now what we're gonna do is that we want to use his rules, so his Yara rules. No, we don't want to use his Yara rules this time. And then we want to use our Yara rules. No, we don't want to scan for replacements. We also don't want to scan for this only. So here you see that it is still using his Yara rules, which I'm not sure why. Let me see. So there's a lot of reds that you'll see. So this automatically also resolves those. Okay, let's continue this. We wait for this to continue. Everything has been processed, which I think this is wrong because it shouldn't be just this many, because this isn't 70,000 files, is it? There's no way this is 70,000 files. Alright, so you have to go all the way up. Yeah, no, this isn't it. The problem is either that I have too many files specified, which is why I think I'm gonna just do. Let me do the path parser to let me find the path parser. Parser. So here's the thing. This tells you exactly how exactly you add custom strings. So let me see our rules. Okay. Okay, this doesn't really tell me much. Okay. Okay, so this is supposed to actually detect it already. Okay. So instead of using 70,000 files, we can use extractions from System Informer, which was my second step, but you can basically get the point now. So since we have gone to the depths of analyzing everything, we go to Explorer Service. BSC says, oh, hello, Barbara joined. Nice. Go to Explorer, go to Options, go to Strings, go to 5. Then what you do is that, first of all, let's verify that this file is found so that we know that. Yeah, okay. Probably is, probably isn't. As an extension, okay. Okay. So we have this file over there, and we want to scan all of the files on the device. So what we do next is we go to the Learn DVR, go to the documentation, go to the home, go to those who send. You can ask this for the regex Gitbook Assistant. So you can ask this for the regex of that you can use for paths. For example, go to Options, Strings, 5, Image Mapped. Then what you do, I think I'm doing this there. Okay, yeah. And then you do this. So the filter rejects case sensitive and ask it to give me rejects on file paths. It's going to send you the rejects that are public, and these are useful regular expressions that you can, rely on. So I recommend that I highly recommend that you use this to learn free stuff first as well, because it's going to help you a lot. I recommend that. I'm also going to make some summaries and stuff here. Okay, so this one is only executables. Rejects for ads. Actually, it's not here. The ads rejects is not here. It should be in course material. It should be in popular. Is it? It's for starters. It should be here at least. Is it not? Okay, that's strange. Behavior, webinars, popular. Should be somewhere here. Paths of radius where it also works because it uses the same rejects. So you can use these rejects. I'm gonna repost it here so that you guys see it too. Use that. Copy the paths. So copy result. Paste them in paths.text. Right, now everything is over here. And then also about the extension SCR, I think it's better if I remove the SC is invoker as administrator of this program, executable files. Yeah, I think that this is not a command. Yara rule samples. So this one doesn't really give us the correct format. It's okay. So you can also use your own repository of Yara rules. So you go to, let's say, anti-debuggers. Go to this Yara rule, and just find this Yara rule. Right? Should be somewhere. Right, okay, so there are a lot of Yara rules over here. Okay. You can use all of those, to be honest with you. Copy that for your Yara rules and paste them. Well, although the issue here is that now this is the issue. So let's just do without separations and leave ours in. So it has to be like that. Right. Now these ones work. Actually work. So then we have the condition. We have any of them. We have closed the bracket, which is supposed to have. Okay, yeah. I mean, the first one is probably not gonna work, but it's still worth trying. So then we use the path parser. Okay. path parser. And then, so just do yes and yes, then no and no. Right, so this one works. Now, this one actually works because, for example, this one just saw or checked that this file has debugger enabled. This one, okay, now this works, okay. So as you can see here, this is what I've been trying to get to this whole time. Fuck. So this detected the weird file that doesn't have an extension, and it says that it has a cheat signature. Okay, everything gets debugger, pattern, debugger, everything gets analyzed. So we exported this path over here, okay, this path. And it turns out that this file now is suspicious, but the first thing that you do is not to modify the file, but to copy the file. Copy the file, paste it here. Turns out the file is hidden because we don't really see it here. And if we do it again, it's going to ask us to replace the file, which means that we have to check the file's attributes. So right click here, go to the attributes. And you'll see that it also has read-only, H, so hidden, and it's an archive, which means that we go to cmd. Run this as administrator, go to the same directory of the downloads. Yes, it was recording this whole time. And go to the downloads directory. Right, and the attribute, so minus means that we are removing hidden and read-only attribute from 1.8 blah blah to a new CLS. Now it's here, okay? Duplicate here. No, it is here, okay? So we have the file now, which means that now this file is suspicious. And there's also a copy of the file. So the next thing you are supposed to do is not to immediately rename the file, but just upload this to VirusTotal immediately. Immediately upload this to VirusTotal before doing anything to the copy of the file. Another reason to why we copy the file is because, so okay, we also see these weird YARA rules, which does what? Identifies compound auto-it script. Okay, so we also have this YARA rule set, which is interesting, because you can also use this in your YARA scripts, so you can just also, add all of that here, and we have that rule. So this is useful, very useful, always very useful to check YARA rules here, because it's actually, interesting. And we also have a truncation of IPv. Okay, so this says that this file is autoclear, so that's what we see here. So the next thing you are supposed to do is that you are supposed to check the file, or just rename this to .exe, and you see .exe, for example, you see that this is an actual autoclear that we have just found on the system. So this obviously doesn't prove that this was used, but we're gonna get to that point very soon. The next thing we have in the file analysis is that when you have all of those files, right, when you have this in the hex editor, so you have just found a bypass, which is also why you actually upload files to VirusTotal. That way you will always have the link to the malware that you just detected. So it is very interesting and very useful to also read all of those. Another thing that you can do here is that create your own rules. So for example, show you the creation of my own rules. You can also add entropy detections to this, but it's not necessary. So let's say we have this rule sample, right? So there's this rule sample, the first one. So for example, this has a meta file, so this is the name, or like the introduction to what this script is. And then we have the category, so it's an info flag, we have the strings, we have the conditions, and then we have this one. We close the brackets here. So we have, if for example we do any of them, right? So any of them, then this is going to have, if any of those strings matches, unit by the way refers to the $sign. If any of those strings matches, then it's gonna flag the file for suspicious, let's say. So what you can do here instead is that you're going to remove these, the unit 16. So this one is basically the dollar sign. You can also have those big names of the rules, which looks like this author doesn't really do that. You replace those as if white means that this will specifically target those ones, those strings. So for example, we want to detect all the files next time that use where is this? That use execution policy as invoker, which means that the host, which is executing the file, is gonna assign its own permissions to this file. So if I execute this as CMD, as admin, the file is gonna execute as admin too. So what you do here is that you copy this. You can also just paste this. Let's say you also paste this here. Let's just do it here, okay? As invoker. Now that's gonna find or flag every file that has as invoker in its memory. Okay, that's useful. Or you can also do as administrator. This is going to flag only files that require administrator to be executed. So that's what you can do for Yara rules and add those to your detection sets, which I highly recommend so that you actually do this. So always create a Yara file before using pathparser.exe. So it's very useful, it's super useful. So that's pretty much all about file autopsy. So how exactly you are supposed to not reconstruct, but understand. So you are not supposed to know that. You are supposed to do it immediately because you are scanning files. You are not supposed to have any hints because you won't get any hints. So you should do this every time you measure, right? Because maybe they have an extensionless file, maybe they have a renamed extension, which is what, by the way, most of the 5M and Minecraft bypassers use nowadays. It's either extensionless files or renamed extensions. For the purpose of renamed extensions, that's I just do !.exe.tll, and then you do file, and then you do size, at least 200 kilobytes to 35 megabytes, okay? And then you have 9,000 files that are likely not cheats, but the indication of this being a cheat is, for example, this one. This one shows you that this is a defendant protected file, and this is the scans of the antivirus, which I can access this if I want to, but do I want to? Yeah, I guess yes. Do I really want to? I know. So okay, you get the point, right? You just do this. Okay, you can't expect anything. You have to do this because you will never know if they have an extensionless file or another style or type of a file. So the worst part is if they modify the file, then that's an issue because then what you have to do for a faster, if they like replace the file or rename the file or delete the file, then what you have to do is actually just recover the file if you are interested in what it exactly is. Or you have to use actual forensic tools like Velociraptor to extract a USN journal that allows you to look for file names without extension. Journal trace doesn't let you do that. But what you can do about journal trace, actually, this is a very funny trick that you can use, is that when so let's say you want to check for modifications of USN journal entries that are renamed extensions. Okay, so let's say you are looking for recent basic info change of a file that has no extensions, or at least not .exe. So what you do here, you click this, you go all the way down. So actually we also need the path. So hold shift, select everything, so everything is selected. So hold shift, click the other one, and copy this. Usually this is gonna crash journal trace. So we wait for this. Usually this crashes, okay, but you continue. You still continue and do the Control-C one more time so that you make sure that you have copied it. Then you open some random file, you paste it here, okay? After you've done that, you just, what you do. It's very easy to guess. You just, where do I have? You just paste this in Timeline Explorer. Another thing is that I can make a script for you guys to turn this into a comma separated value, so it's like a actual internal extraction with a CSV, but just paste it here. And what you have to do now is that, let's say you are looking for files that don't have an extension. You go to the filters, does not contain, and we'll just do, let's say, no .exe files. Okay, every executable file is gonna be exempt. Or let's say you want all the files gone from the search that have a dot in them. So dot. Now this usually has better chances of giving you actual traces or actual files that have no extension, because extensionless files always, almost never have dots in their names, but sometimes they can just rename the extensions. So that's just how you do it, right? So you're searching everything here now, and you also should sort by the dates. But it will be better if I actually made a script to format this for you. It's easier. It's an easier user journal search when it comes to that. So yeah, there is that about the journal trace. Otherwise, you can just use a different utility to support using journal. Now another thing is that welcome back. Now another thing is that you can also use what I lost. You lost practice, I guess. But schools is recording, so that's good. Another thing that you guys can do also is like inspect an executable file. So when you find the malware or a file that you think, for example, hides itself, when it hides its GUI when it is executed with Ndesk. So you can inspect this, okay? Inspect the file. The main things that you are looking for are imports and exports. Where are the exports? Exports? No. Okay. So you have the imports. So these are gonna tell you exactly what the file does, right? So for example, the name is the imports name. So this one, let's see, connects socket. So this also establishes a network connection for some reason, but okay. Then you also have streams. So is this an alternate data stream, or what's the size of the file? What the size of the file is, you can also just check for the strings of the file, which is, ASCII delimited strings. So if you're analyzing a malware that you just found, right, so this user object information, so you can also extract strings from here as well. Okay, goodbye, W. So I'm gonna send you the video too, and I'm also gonna be making analysis. So you analyze those files. So for example, this one, this is a compiled autoid script because this is a OP autoclicker, which is why the other detector also detected it, the Gara rule. Right. So those are the strings. There's also a which is a MUI. There's a version of the file. There's the symbols of the file. Preview just gives you a notepad view of the file, which is gonna lag the system. So you can also just check the processes. This one is not necessary. And we have the links, so exactly the file is, if it is a junction or a systemic or symbolic link, it's going to also show you the other directories of the file. So let's say this is one of the ways that you can also detect systemic or hard links with. So if let's say you find the file, you suspect that it's are we on system format? Yes. Yeah, if you suspect the file is a systemic or symbolic link, or a soft link, hard link, you can use or check that over here. Alright, you can check the layout, so the rest that don't really don't really matter. There's also certificates which give you the certificate information, which I mean, you can also use this to check or at least guess if the certificates have been modified. Because there you have the issuer, you have the dates of the certificates. So yeah, although these ones are the dates of the certificates, and yeah, well, this one won't really tell you if the file is. So you go to System Information, go to Tools, and go to Inspect Executable File, and then you select the file that you're analyzing, and over here. You also have the ID of the file. Well, this is not really that important, but this gives you the general ID or structure of the file. So this one is a C file, C++ file. You also have the manifestation, which is where you find the execution levels. So the rules for the execution. This is with as invoker. You have the resources as well. And this is the resources are like what the file comprises of. So for example, this one is icon, group icon. Saving the resource doesn't really give you much. It's just just a file that you can just open. What is it? There's everything documents. Where does it? Yeah, this is basically nothing because it just shows you the same, the icon or whatever. Well, I don't think that this is also says PNG, to be honest, because it's just a data file. Yeah, no, it's not. There's no icon. These resources are easily viewable with resource hacker or resource. Yeah, so any application that can view resources, and as I already said about sectors, these ones are logical. So sectors of the file, and those are just the characteristics. So is it executable? Is it a readable file? This is code because, as we said, the file is a script compiled, as we saw in strings. So I think it was in. Let me see where it was. So this is a compiled. Let me find compiled. Right. So this is a compiled Autopsy script. That's why it also says in the sectors that it's a code. So there's that. We also have the headers, which you can sometimes use for static malware analysis. And for example, this one has an entropy level of 7.9, which means that for the file entropy detectors, so how fluctuate the file data is. So those can also be used for detection purposes, especially with Yara. Do you guys have any other new questions? I guess you guys have no more questions. Okay. With that being said, the extended course webinar is over. And we're gonna go to the. Okay, what is your question? Okay. So with that being said, you can stop the recording now, schools.